In this video, we're going to talk about the rules for indices. Indices are when we raise a number up to a power. An example of this you might see in quadratic equations would be where you would see an x squared or you'd see an x cubed. If we see that example of that with real numbers, we could have 3 to the power of 2, which is equal to 3 times 3, which is equal to 9. But indices have got a few rules that are attached to them and based on how they interact with each other. So we'll look at the first rule we're going to look at is the multiplication rule. In the multiplication rule, if we have x to the power of a multiplied by x to the power of b, the answer to that will be x to the power of a plus b. Well, let's see an example of that with real numbers. So if we had x squared plus x cubed, the answer to that would be x to the 5, because we would add the 2 and the 3. But we can demonstrate this out by actually drawing it out. So x squared is x times x, and we're multiplying it by x cubed, which is x times x times x. And if we count that up, that's 1, 2, 3, 4, 5 x's being multiplied together. So that's equal to x to the 5. So that's why the multiplication rule works that way. The next rule we're going to look at is the division rule. In the division rule, we say that if we have x to the power of a over x to the power of b, that's going to be equal to x to the power of a minus b. And we can look at that with an example just to start with. So say we had x to the power of 5 over x to the power of 2. That would be equal to x to the power of 3. But let's see that if we actually work the numbers out. X to the 5 is x multiplied by x multiplied by x multiplied by x multiplied by x. That's the 5 x's. And if we put that all over x multiplied by x, we can, because everything on top and on bottom is being multiplied, we can actually start cancelling some out. So this x on top cancels this x, and this x on top cancels with this x. So there's nothing left on the bottom, and we're only left with 3 x's on top. So that's going to be equal to x cubed, like that. So that's how that one works out. So that's the division rule. The next rule that we're going to look at is power to a power. So what happens when you raise a power to another power? An example of that would be if we had x to the a all to the power of b. Well, that would be equal to x to the power of ab, or a multiplied by b. Let's see an example of that with some real numbers. So if we have x to the power of 2 to the power of 3, that's going to be equal to x to the 6. But we can actually draw that out. X squared to the power of 3 is x squared multiplied by x squared multiplied by x squared. And if we look back to our multiplication rule, the very first rule we looked at, when you're multiplying powers, whether you've got the same number and different powers, you can add the powers up. So we've got x squared times x squared times x squared, so we can add up our 2's, in which case we're going to get x to the 6, which is exactly what we got from following the rule just above. So that's power to a power. The next one up that we're going to look at is product to a power. So if we have xy to the power of a, that's going to be equal to x to the power of a times y to the power of a. And we can take a look at an example of this. So if we have xy all squared, that's equal to x squared y squared. And we can kind of see that makes sense if we multiply it out. Xy squared means xy multiplied by xy. Well, xy is just x multiplied by y. So we have x multiplied by y multiplied by x multiplied by y. And since it doesn't matter what order we multiply things in, we could rearrange this slightly and we could get x times x times y times y. Well, x times x is x squared and y times y is y squared. And when we're multiplying variables like this, we don't need to write the multiplication in between, so we just get x squared y squared, which is exactly what we're expecting based on the rule that we wrote above. So that is power to a power. The next one up that we're going to look at is fraction to a power. So if we have, for example, x over y all to the power of a, that's going to be equal to x to the a over y to the a. And we can take a look at that with a real number example. So if we have x over y all to the power 2, that's going to be equal to x squared over y squared. And let's work that out. So x over y all to the power 2 means x over y multiplied by x over y. And when you're multiplying fractions, you multiply the numbers on top together, and then you multiply the numbers on bottom together. So x times x is x squared, and y times y is y squared, which is exactly what we got from the rule above. So that is fraction to a power. Next up, we're going to look at power of 0. So the rule with this is any number at all, absolutely any number, to the power of 0 is equal to 1. And the way we can prove that this works is, let's say we see an example of this. So say we say x to the power of a all over x to the power of a. Well, any number divided by itself is equal to 1. We know this to be true. 3 divided by 3 is 1. 5 divided by 5 is 1. A million divided by a million is equal to 1. So that would mean that x to the power of a divided by x to the power of a is equal to 1. But we can also say that x to the power of a over x to the power of a is equal to x to the power of a minus a, based upon our division rule when you've got a division like that with powers involved. And x to the power of a minus a is equal to x to the power of 0. So if x to the power of a over x to the power of a is equal to 1, and it's equal to x to the 0, that means that x to the 0 is equal to 1. So that's how we can prove our power of 0 rule works, just like that. And the next one up that we're going to look at is a negative power. So if we have x to the power of minus a, that's equal to 1 over x to the a, like that. So if we did that with an actual number, we could have x to the minus 3, and that's equal to 1 over x cubed. And again, this can be proved with the division rule. So let's say we had x to the power of 2 all over x to the power of 5. Well, if we do a little bit of cancelling on this, this is going to be equal to 1 over x to the 3. So that's just by cancelling it down like this. But if we apply the division rule to this instead, then it's going to be equal to, we're going to have x squared over x to the 5 equal to x to the 2 minus 5, based on our division rule, which is equal to x to the power of minus 3. So we can see that x to the power of minus 3 is equal to 1 over x to the power of 3. So that is our negative power rule. Right, the next we're going to look at is fractional powers, and we're going to do that in 2 parts. Okay, so for our fractional powers, if we have, for example, x to the power of 1 over a, that's equal to the 8th root of x. But we'll see this was an actual number now. So say we have the x to the power of 1 over 2. Well, that's equal to the square root of x. And we can kind of prove this out a bit using our multiplication rule. So if we square both sides of this, so we take our rule here, which is x to the half equals to the root of x, and we square both sides. X to the power of a half to the power of 2, if we use our power to a power rule, is going to be x to the power of 1/2 times 2. So this is just x. And when you square the square root of a number, you just get the number itself, so you get x. So you can see why the fractional power rule holds. But this also works with another way where you have x to the power of b over a. And that's going to be equal to x to the 1 over a to the b. So let's see an actual example of that. Say we had x to the power of 3 over 2. That's going to be equal to x to a half cubed, which is going to be equal to the root of x cubed. And this particular rule on the top here is based upon doing the power to a power rule in reverse. So if we multiply these brackets out here on our right at the top, we're going to be multiplying our b by 1 over a, and we'll just get b over a. So it works as our power to a power rule, but in reverse for this one. And those are the rules of indices. And that is that.